In the second part of this course, which was about diodes, you learned how to model a nonlinear diode so that you would be able to analyze diode circuits by using conventional circuit analysis techniques such as mesh or nodal methods. In this chapter, we are going to do the same. First, we construct a general large signal model of a BJT transistor. We use this model for DC analysis and finding operating point and bias conditions, exactly the same as what we did for diode circuits in the previous part of the course. In the next chapters, you'll learn how to use a BJT transistor to amplify small signals. So in the next chapters, we'll develop a small signal model of a BJT for AC analysis. We will use large signal values from the DC analysis to find small signal parameters of the transistor. Therefore, we need to go step by step. First, we have to learn how to use a large signal model to perform DC analysis. After finding large signal values, we will use them to find small signal parameters. Then, based on these small signal parameters, we can perform a small signal or AC analysis. In the first lecture, I mentioned that the BJT has two junctions. The two junctions, which are base emitter and base collector, can provide different operating conditions. In all the examples of the previous lectures, we assumed that the transistor is operating in the forward active region. Actually, when we are using a transistor for analog applications like amplification of small signals, we need to be sure that the transistor is always operating in the active region. So by using an external circuit, we have to bias our transistor to ensure it will never get out of the active region. Transistors can also be used to operate as a switch. For example, we can use a BJT to open or close the contacts of a relay, and this relay can turn on or turn off an electrical device. In this case, when we want to turn on a device, we use the transistor in saturation mode. And if we want to turn off the device, the transistor should be in the cutoff region. In this case, we simply say the transistor is on or off. Another example is using transistors in digital circuits. In digital electronics, we have two states, high and low, or on and off. In these types of circuits, we have to ensure that the transistor is operating in the saturation or cutoff region. In this course, we mainly use BJTs to build amplifiers. So for the amplification purpose, we use it in the active mode region. I will also show you some examples on how to use a BJT as a switch. Up to this point, you have encountered components that had two terminals or one port. These components are easy to describe as you are only dealing with one voltage and one current. For example, you can easily illustrate the IV curve of a resistor. The current is simply the only current passing through the resistor, and the voltage is the voltage difference between its terminals. Another example is the diode. The diodes you saw before was nonlinear, but had two terminals or one port. So when the applied voltage to the P side or anode was greater than the built-in voltage, current would flow through the diode. Otherwise, the current was approximately zero. So for those one-port devices, we could simply indicate the current voltage characteristics by a simple IV curve. In a bipolar junction transistor, we have a different story. Here we have a device with three terminals. So we have multiple currents and multiple voltages. As I told you before, in most applications, we use BJTs as an amplifying device. And because a BJT is a three-terminal device, there is more than one way of using it to provide amplification. If we use one of the terminals of the transistor as a common reference point, then we can say that we have a two-port device. The two other terminals are served as input and output connections. So, depending upon the terminal which is used as a common terminal, we can have three different configurations, and each configuration may be constructed by using either NPN or PNP transistors. You should always keep in mind that if you are going to use the BJT as an amplifier, it has to be in the active region. So, in each of these arrangements, the transistor's base emitter junction has to be forward biased, and the collector base junction has to be reverse biased. In the next video, I'll discuss the current voltage characteristics of the BJT based on these configurations.